Hi guys, welcome to another episode of Building a Modern Data from Scratch. And this is going to be our final episode. We're calling it a wrap. So we've covered quite a lot from the first episode and down to the last episode, right? So in this episode, we're just going to be talking about tips and best practices on what we've discussed so far, from extracting our data from a Postgres data source down to building our dashboard on Preset Cloud. So that is just what we're going to basically cover in this episode. So I will just go from top to the bottom, or from first to the last in that particular order. So without wasting much time, let's get into it. So over the past few episodes that we've already discussed, we walked through using some of the most powerful open source tools and cloud-based tools out there, right? From Postgres to using Airbyte to using Snowflake for our data warehouse, leveraging dbt for our transformation, and using good expectation to validate our data products, and using GitHub Actions for automatic deployment of dbt documentation to CI/CD, and orchestrating audio process using Airflow, and we kind of implementing infrastructure sitting right on Docker to building our dashboard and preset. So just as I said in this last episode, we're just going to share some pro tips and best practices I've learned from building and monitoring these kinds of pipeline in the real world environment. So whether you're a data engineer, you're an analytics engineer, or someone kind of exploring modern data tooling, this session is going to help you to build pipelines that are scalable, reliable, and production ready. So let's do a thinking about ALT paradigm. Before now, the common paradigm that has been was the ETL paradigm, and so the traditional ETL paradigm which involved transforming data before loading it into the data warehouse. But with the power of modern cloud data warehouse like Snowflake, BigQuery, and Redshift, we can now load first and transform later. So which leads us to the ELT paradigm. So the benefit is the flexibility that we have, that raw data stays intact. Our raw data is sitting within our data warehouse, and we don't necessarily have to go back to the source in order to make some changes if probably some requirements are being requested from the stakeholders. We don't necessarily have to go back to the source to start fetching those changes. So using the ELT paradigm, we extract everything from the source and it sits there in our data warehouse. So with that, analytics team can iterate faster if any additional requirements comes to play. So the pro tip here is always keep your raw data immutable. That is, treat it as your single source of truth, and every transformation should happen on top of a dedicated schema or layer, like your staging, and from there you go to your intermediate and into your math layer. So talking about the Airbyte tool that comes into play in our extract and load part of the pipeline. So our pipeline began with Postgres as the source and Airbyte as the extraction and loading engine, which makes it simple to configure and schedule connections. But there are best practices. One is schema mapping, always defining your naming convention for your destination schema. Use something like raw_Postgres just to stick to a particular naming convention. Right? The use of incremental syncs, I may have mentioned it before, but it's important that for large data sets, you enable incremental updates instead of having to use full loads in order to save cost and time. Though you can also decide to do some full load updates during weekends, but incremental updates is very essential for large data sets, especially during weekdays where there are a lot of activities. Also, normalization, data normalization. If you use Airbyte to build built-in normalization, review the SQL logic it generates to ensure that data types align with your data warehouse. And talking about secret management, you want to also ensure that credentials are not stored as plain text. Use environment variables or a secret manager like AWS Secret Manager to store your secrets. And always also ensure to test your Airbyte jobs locally before pushing to production in Docker. This helps isolate connection or any issues. And down to the transformation phase of our pipeline, which is DBT. You want to ensure that you follow a particular model structure, just as we used in the series that was in one of the episodes where we used DBT extensively. We used so we used this approach where we have like the staging, then the intermediate followed by the math. So you follow a particular naming convention in that order. Ensure that your staging is one-to-one representation of your raw data. So whatever you are bringing from your raw to your staging, let it map one-to-one. Your intermediate should form your clean, joined or enriched tables where you have done your calculations, your join and stuff. And your math should be a business-ready data sets where you have your dimensions and your facts, right? Then the end users can easily connect and write their SQL and stuff, right? So defining your sources in YAML file is also essential. So we did something similar here. Defining your sources in the source.yaml file, and also testing and documentation. You want to ensure that you write some schema tests, like you have basic unit test in DBT, like unique, not null relationship for key columns. You want to also do documentation, like adding description to your models and columns in order to also help to drive collaboration within the team. And then using macros and Ginger for logic reuse in your model is also essential to keep everything very compact and to avoid repeating SQL logic within your code. And it's also important to note that you want to also ensure you use incremental models in large data sets. So you can also implement incremental logic within your materialization, and avoid selecting or select all in your models. You want to explicitly select the columns that are needed. All right. So pro tip, enable DBT Slim CI logic using GitHub Actions. We did that in one of the episodes where we use Slim CI logic in order to help with testing additional changes. So if you needed to make some changes to your models, you want to ensure Slim CI logic is implemented using GitHub Actions to test whether the change that you made is not going to break the production tables. So having said that, when you are making changes to your models, you also ensure that you also use feature branch. You don't want to make changes directly on the master branch. You want to ensure that you use feature branch, develop your change, and perform a pull request, which will trigger some CI job to run to ensure that your change works well. And you also implement uh, reviewer implementation in your GitHub. Ensure that people review your code before it's being merged to the master branch. And definitely automatic deployment of your DBT models, either to GitHub pages or to S3. So that's been said on the DBT side of things. So let's go into the data validation, data quality assessment part using good expectations. So for good expectations, the essence of it is that you want to ensure that you are serving data, quality data to the end users, which is our stakeholders in this case. So with good expectation, we're able to add extensive validation and stuff to our code base. So we want to store GX configs and expectation in Git for versioning, and also separate critical versus informational expectations. Not every field test should actually block your pipeline. There are some tests whereby you just want to know that, you just want to have that knowledge there that, okay, these things are happening. It doesn't necessarily have to, it's not important for it to block the pipeline, but there are critical data quality checks whereby if it's been noticed, then there has to be an halt to whatever is going on in the pipeline and go in there and fix it. Maybe the issue of having duplicates, because that kind of situation is critical. You don't want duplicate value to go into the production table and the analyst starts reporting numbers that are not there, right? So also storing validation results in S3 or database for observability. We also integrated our good expectation checks into Airflow, and we're able to put everything together and ensure that it runs after the DBT job has finished running. So about orchestration, that even leads us to orchestration with Airflow. And you want to keep your DAGs modular, e.g., responsible for a clear process. So your tags in each Airflow DAG should be modular. Each tag should solve a particular problem one at a time. You shouldn't have a single tag do multiple things at the same time. So you want to make your DAG modular as possible. I want to also add retry logic and alerts on failures if some cases whereby DAGs might just need a retry. Maybe there might be cases of intermittent connection, and you just want your DAG to try the job once and you start triggering failures, and you have to like go in there and be fixing things. So you can have like retries like 5 times, maybe every 5 minutes retries, and before you start to like look into whether there's an issue or not. And parameterizing your DAGs is also important to keep things clean using Airflow variables. And you can also store logs in persistent storage like S3 or Google Cloud Storage. Some pro tip is also use Airflow tags dependencies wisely. You want to use some operators in Airflow to build your dependencies, and to make your Airflow code clean. And also you want to ensure that probably you test your Airflow logic in a separate environment like UAT, right, or test environment before you deploy to prod, so you can see how the dependencies fit together, and if there's any error in the code, and also ensure that CI/CD runs on your airflow uh, airflow DAGs to ensure that everything fits well, right? And also ensure that you set dependencies between the airby job, the DBT job, and the create expectation job. So it should follow in that particular order. For a Docker environment, you want to ensure that Docker Compose the YAML file. You want to use that to define all services running from Postgres, Airby, DBT, Great Expedition, and Airflow, and mount volumes to persist configurations. And the pro tip: build and test locally before pushing your codes to production. So, and lastly, in this episode, we're just gonna cover pro tips and best practices in Pixel Cloud. So, I mentioned in the last episode that's where you discussed extensively building dashboard on Pixel Cloud. So you know that it extensively relies on SQL, right? Either you are building a virtual or a physical data set, and we have to build an additional physical data set on top of our data mart tables in order to build our dashboard. And some virtual data set can come into play where we have to use it to create charts from metrics, right? So you have to know when it's ideal for you to create virtual data set, because some logic is best when it's being generated from a virtual data set than having to put too much effort and complexity on the physical data set, since it will involve some aggregations and some aggregations. So you want to create a separate virtual data set that puts those SQL aggregation logic into SQL and save it as a virtual data set. I think, let me just share that. So that will lead us to our preset. Let me log in to. I think that will give us we have a dashboard that we built from the last episode, and we built some data set from there. Let me load this. Charts data set. So these are some of the virtual data sets that we created: store metrics, product metrics, which are built from physical data sets like our OBT table, Jaffle OBT. So writing those SQL logic is going to make it a lot easier for us to build our charts. So on that, also using filters, parameters, and drill downs for interactivity on your charts, making use of macros, Ginger to apply filter logic. A majority of our virtual data sets use Ginger within the query to ensure interactivity within the dashboard, so that our charts can be filterable. We can filter those things based on the filter that we applied on the dashboard level, which we filter the data set to give us the desired value that we want. This is our dashboard. To dashboard level. I think. Okay, let me go from here. Dashboard. So this is the Jackfruit Shop Analytics. So based on our filter, any filter that we apply here, so depending whether the virtual data set is Ginger enabled within the query logic, it filters and gives us our desired result. So for instance, where you have customer, let me say transaction analysis, and this is the total orders, total revenue, total profit. Imagine I just select a product name and select the stew and apply, then it should typically affect so this is total revenue for this particular product, total profit. That is as a result of the Ginger that is being used within the virtual data set. So if you look at view query, you will see where that was applied. So you can see where product name in this. So that's the essence of using Ginger within your virtual data set. Also, because if you're using a free trial, the free version, you don't have access control to your workspace. But however, if you're able to upgrade to the team plan, you want to ensure that there's access control to your workspace in order to avoid people making changes to your dashboard or deleting something that you really do not want them to delete. So that's very important. And also caching to improve dashboard performance. You don't want your dashboard to be eating the data warehouse every time when you apply maybe a filter or something. You don't want, because it's if you apply a filter, you apply it, it has to like refresh, right? So all those refreshing, you don't want it to start eating the data warehouse to get those results. So when you enable caching, depending on the time frame that you've already selected and it's already been cached, it doesn't have to go to the warehouse to fetch those results. So pro tip here is to connect Pixel directly to your Snowflake warehouse to see live data updates in near real time, definitely. So I think we're going to cover everything that been discussed from the start to from the start to end, right? So just to wrap things up, automation is key. You don't want to build a pipeline that you have to be triggering manually. Observability is also important. Always monitor your jobs, the logs, and the health of your data through data quality assessment, documentation. You want to keep everything transparent for your team. And apart from that, it also helps with collaboration, and it also helps with if a new engineer is brought into the team, it's really going to help to split things up, to help the new engineer understand context, and it's going to reduce the number of questions that the engineer may have, right? Because most of those questions would have been answered through documentation. So iteration, start simple, then add complexity as the data maturity grows. So and that wraps it up for our Modern Data Stack series. I hope this series helped us to understand and not just how to build pipelines, but also how to build them the right way. I hope you found this very valuable. So if you do, give it a like, subscribe, drop your questions or future topic ideas in the comments. Share this video with your friends, your colleagues at work. That being said, until next time, keep building, keep learning, and keep your data pipelines flowing smoothly. Thank you.